Good afternoon, all. I'm audible.
Yes, ma'am.
Screen
Yes,
is visible.
yes, ma'am.
Okay, thank you. Okay, thank you. So let's start the lecture. So in the last lecture, we have seen some of the algorithms from chapter number 6. That was shortest path routing algorithm. We have seen the examples of it, how to find the shortest path from source to the destination that we have seen. Then we have seen the next algorithm, which was the link state routing algorithm, which executes or which happens by using these five steps. And one by one, every step we have seen how the packets are generated. And last algorithm that we have seen was the distance vector routing algorithm, which is also called as the DVR algorithm, or the second name is the Bellman-Ford routing algorithm. Okay, so how this works? So just it is nothing but every router maintains its own routing table, right? And in that routing table, it just maintains or it all the information related with the neighbors, means how far that neighbor is from the particular router. In such way, these routing tables are always updating. That was the algorithm, but there it is having one property or the feature is that this information or the routing table information is shared only with the neighbors. Okay, with the help of these routing tables we can find the path easily, but this information is shared only with the neighbors. And due to this, the main problem arise, that is nothing but the count to infinity problem. Okay, that also we have discussed in the last lecture. So quickly I'll show you what is count to infinity problem. So count to infinity problem is what? These are the five routers, right? And everyone wants to reach to the, for example, A. Okay, A router, and they have to find how much the distance to reach to A, and the distance is to be considered in the number of hops, means number of these lines we can say. Okay, so by according to the neighbor's condition or neighbor's position, everyone updates their own table. So initially no one knows how many hops will require to reach A. So initially the distance is dot, or we can say it is an infinite, is it is not updated yet. But suppose B finds that B is reaching to A by using one hoop. Okay, so this table is updated as 1. As soon as B updates 1, C also updates its own, because C reaches to B by using this one hoop, and B is reaching to A by using this one. So 1 plus 1 2. Likewise, everyone updates their own tables. Okay, up to this it is all okay, everyone is having information or everyone is having way to reach to router A. But if suppose this connection between A and B get lost, okay, or this connection is getting lost between A and B, then what happens is that as this connection is getting lost and this information is only with B, because B is the immediate neighbor of A, and the information of the router is being shared with only B, not C, D, and E. Okay, so initially they are having the values as 1, 2, 3, and 4. But if the connection is getting lost, B understands that no, I cannot reach directly to A. But B understood, so B sees that C is reaching to A. So what B will do? B will see these two and update these 3. That is 2 of C and this one hope to reach to C. Similarly, as soon as B updates, C also updates its own table as a 4. There's these 3 plus 1, that is 4. Likewise, without knowing the situation of breaking the connection between A and B, everyone goes on updating their own table. They just goes on adding the number of hopes in their own number, and at some condition they will reach in a position that nobody is reaching to A, still they are updating the table, and this is called as a count to infinity problem. right? So this problem we have discussed in the last lecture. I hope there is no issue with this problem. Anybody is having any question related with this? It is easy, just you have to observe what is happening in the tables, and likewise you have to update. Don't means हे सगळं पाठ करायची वगैरे गरज नाही. You have to just update the numbers over here according to the earlier numbers. कोण कोणाचा नेबर आहे आणि त्याचे नंबर्स कसे अपडेट होणार आहेत ते फक्त बघायचे. Accordingly your table will get updated. Okay, so this is called as an count to infinity problem, which arises in the distance vector routing algorithm. Remember this. Okay, the question may be asked for the MCQ. Now the next is that what will be the solution to overcome this problem? Distance vector routing algorithm gives the problem of count to infinity. So how to overcome this? So there is one solution which is called as the split horizon rule. Okay, this is the solution to overcome the problem of count to infinity, because count to infinity problem is nothing but it goes on a looping. Okay, means looping means what? लूप्स म्हणजे काय असतात की इनफायनाईट वे साठी आपण तो एकच गोष्ट कंटिन्युअस एक्झिक्यूट करत राहतो. मीन्स कुणालाच काय कळत नसते, फक्त एकमेकांच्या सोबत कनेक्शन्स होत राहतात. सो दॅट इज नथिंग बट द लूपिंग, अँड दॅट इज द मेन रिझन ऑफ काउंट टू इन्फिनिटी प्रॉब्लेम. अँड टू ओव्हरकम दिस problem, split horizon rules are used. I'll tell you what is this exact rule. So it dictate that routing information should never be sent out an interface it was learned from. What is the meaning of this? So see this figure. Suppose uh, in this figure R3, this router 3, this is providing the information to the other router, those who are connected. So we can say that R3 is connecting with the R5, then R4, and then R1, because they are immediate neighbors. Immediate neighbors म्हणजे काय, तर ते डायरेक्टली त्याला कनेक्टेड आहेत. Okay, now R3 is connected to R4, R5, and R1, so they are providing the information to these three routers. Okay, now obviously R4 will provide the information to this R2, and R2 will provide or communicate with the R1 and R4 as per the immediate neighbor rule. But suppose this connection is getting lost, that is R3 आणि R5 मधलं connection lost झालं. So according to the count to infinity problem, what was happening, the connection is lost, still B is trying to connect with the A. करेक्ट, आणि त्याच्यामुळे हे सगळे पुढचे इन्फानाइट नंबर मध्ये किंवा इन्फानाइट लूप मध्ये हे जात होतं, बिकॉज the connection is lost, still B is trying to connect with the A, and that is the reason for count to infinity problem. Now according to the split horizon rule, what it indicates that, it indicates that information should never be sent out on interface it was learned from. Means एकदा याच्याकडून इन्फॉर्मेशन R3 ला मिळाली, R5 कडून याच्याकडे कनेक्ट झालं, मग जरी R5 R3 ला डायरेक्टली कनेक्टेड असला तरी सुद्धा परत त्यानं कॉन्टॅक्ट ह्याला करायचं ना. हा कोणाला कॉन्टॅक्ट करणार, फक्त R4 आणि R1 ला. करेक्ट, मग हे जरी कनेक्शन लॉस्ट झालं तरी सुद्धा R3 ह्याला कनेक्टच होणार नाही अकॉर्डिंग टू स्प्लिट हॉरिझॉन रूल, आणि तो कनेक्टच झाला नाही तर ऑब्विसली R5 पण ह्याला कनेक्ट होऊ शकणार नाही, R1 पण कनेक्ट होऊ शकणार नाही, आणि R2 चा तर प्रश्नच येत नाही. Right, in this way this looping can be avoided. Similarly, forget about R5. Suppose this information is being transmitted from R4 and R3. काय होते, R4 कडून R3 कडे information provide होते, and somehow suppose this connection is getting lost. हे connection lost झालं. What will happen? Obviously same condition as like count to infinity problem. So according to this rule, once the information is passed from R4 to R3, R3 should not again contact to the R4. R4 ला कॉन्टॅक्ट करायचं नाही, ज्याच्याकडून इन्फॉर्मेशन येते त्याला पुन्हा कॉन्टॅक्ट करायला जायचं नाही. In this way, count infinity problem can be avoided, or looping between the routers can be avoided. Okay, are you getting? Yes. Hmm? What is split horizon rule? समजलं? Hmm? So रूल जरी एक्झॅक्ट समजलेला नसला तरी लक्षात ठेवा की काउंट इन्फिनिटी प्रॉब्लेम कॅन बी अवॉइडेड बाय युझिंग स्प्लिट हॉरिझन रूल. रिमेंबर दिस. Okay, so this is the way how we can avoid the looping in distance vector routing algorithm. Okay, I hope this algorithm is clear. Yes, any doubt? Okay, I hope it is clear. So let's move to the next algorithm, that is nothing but the hierarchical routing algorithm. Okay, hierarchical routing algorithm. Now, why this algorithm is used? So if the network grows in size, okay, if the size of the network increases, then the routing table also grows proportionally. Obviously, जर सपोज साईज वाढत गेली तर काय होणार आहे की प्रत्येक राउटरचा स्वतःचा टेबल असणार आहे. सो ऑब्विसली प्रत्येकाला काय करणार आहे की इन्फॉर्मेशन अपडेट करताना तो टेबल इन्क्रीज होत जाईल. सो if the network grows, then routing tables also grows. Not only router memory consumed by ever increase the tables, but more CPU time is also needed to scan or to store all the information. So obviously bandwidth is also required, which is highest. So in short, if the network increases, then the routing table, then to processing time, as well as to store all that information bandwidth required, it also goes on increasing. So it is required to minimize this load within the network. Okay, now how to minimize this load, that is shown in by using hierarchical router. At certain point the network may grow to the point where it is no longer feasible for every router to have an entry for every other router. सपोज एका नेटवर्कमध्ये 1000+ राउटर झालेले आहेत. सो प्रत्येक राउटरला इन्फॉर्मेशन सेव्ह करावं लागणार त्याच्या नेबर्सची. सो इट इज नॉट फिजिबल. So the routing will have to be done hierarchically. So for that purpose, hierarchical routing is used. Now, how it is used? So instead of having one network for all these nodes, it is divided into the number of regions. See the figure. Okay, you can see here region 1, region 2, region 3, then region 4 and region 5. Instead of having all the routers in single region, okay, in single region or single network, what is done in a hierarchical router, all these routers are divided into the small regions. Okay, so this is called as an hierarchical router. Now what will how it works actually? So in case of this region, for example, let's take an example, region 1. Okay, in region 1, A, B and C, these three routers are available, A, B and C. In region 5, these two routers are available, Q and P. Now, in case of this region, every region or every router is aware about the router which is available in that particular region only. Means what? This A router is known that B and C, only information related with the B and the C. Means A will have a routing table of B and C, only these two routers. A is totally unaware about these routers D, E, F, G or I, L, whatever it is. Okay. Similarly, for example, D router is there. So this router will be aware about E, G and F. Only these three routers. Not about AC, A or QP or NM, whatever it is. So every router is totally aware about the router which are available within the region only, not out of the region. Now, how the tables will get maintained then? So obviously by using the hierarchical routing, this routing table or the load of the routing table is getting reduced. How? I'll show you. Okay, see the first diagram. Okay, see this diagram. So these are the routers. Okay, and these are divided into the 5 regions. Now, before, if we don't use the hierarchical routing table, ओके, जर आपण हायरार्चिकल राउटिंग टेबल यूज नाही केला तर एका राउटरला कुठल्या कुठल्या एंट्रीज मेंटेन कराव्या लागतात. सो दॅट इज शोन इन फिगर बी. In this figure, let's say this example is related with the 1A router. 1A is this one. Okay, now what is this given? 1A to 1A distance will be 0, means there is no line. 1A to 1B, so it will reach to 1B by using this 1 hope. Okay, then 1A to 1C, it will reach through 1C by using 1 hope. Now 1A to 2A, so it will reach to through 1B. Okay, for example this one, so it will require 2 hoops. Similarly 2B, again it will require 3 hoops, like this, and so on. So if we consider only one router, that is 1A, and if we maintain the routing table from 1A to every other router within a network, so if we count it, it will require total 17 entries in one routing table for one राउटर. एका राउटर साठी 17 एंट्रीज लागणार आहेत एका राउटिंग टेबल मध्ये. ओके, इनिशियल स्टेजला इट मे गेट अपडेटेड अगेन. So this is the condition without using the hierarchical routing. Now suppose these are divided into the number of regions, as like this region 1, region 2, 3, 4 and 5. Now what will happen? Same table for 1A will be reduced to these entries. Now you can see here 1A to 1A, so there is no hope required. 1A to 1B, 1, this one, then 1A to 1C, this one, that is 1, then this again. ओके, वन्स इट कम्प्लीट्स दिस पर्टिक्युलर रिजन. आता हे सगळ्या एंट्रीज झाल्या रिजन 1 मधल्या ए बी अँड सी. नाव रिलेटेड टू द पार्ट 2. ओके, that is region 2. So for that it will maintain only one link. Okay, you can see here this is the region number, that is destination is what? Region 2. Okay, so this 1A will reach to region 2 by using this 1B. Okay, so this one and this 2. So once it will reach to region 2, region 2 will have a separate routing table. तो मेंटेन करायची 1A ला गरज नाही. Okay. Similarly region 1, तर 1A to region 3, it will reach through 1C this way, 1A, 1C and this one. Okay, by using 2 hoops. Similarly region 4, so it will reach through 1C, so it will go to this one and this one. So number of hoops will be 1, this 2 and this 3. So here 3 is given. And region 1 to region 5, it will require 4 hoops. So again by using this, it will just go to by using 1 line. So 4. Okay, so you can see here 1, 2, 3, 4, 5, 6, 7. Only 7 entries are required by using hierarchical routing algorithm. Is it clear? Yes. Yes, remaining student only Pratibha Suryavanshi and some 2 3 students are answering every time. Huh? They are just responding me. What about others? I don't know. Yes, others. Have you understood? Hierarchical routing, why it is used and how it is implemented. Any doubt? Doubt असेल तर विचारा. Okay. I hope it is clear. No doubt, no? Should I repeat? I think it is clear. Okay. ठीक है. So the next algorithm is the congestion control algorithm. Congestion control algorithm. What is mean by the congestion that is given when too many packets are present in the subnet or we can say in a network, then performance degrades. Okay, when too many packets are present in a subnet, performance degrades. We can take our example also. ज्यावेळेस खूप साऱ्या गोष्टी डोक्यात चाललेल्या असतात त्यावेळेस काय होतं लेक्चर मध्ये काय चाललंय we don't know. It is nothing but the congestion. Okay, when too many packets are present in the subnet or the network, then performance degrades and this situation is called as a congestion. जे गर्दी खूप गर्दी झालेली आहे आणि त्यामुळे काय होतं तर परफॉर्मन्स डिग्रेड होतो आणि ह्या सिच्युएशनला काय म्हणतात तर कंजेशन. Okay, so congestion is a situation where too many packets present in a network which degrades the performance of the network. So you can see here, this is the maximum capacity or maximum carrying capacity of a subnet. So एका सबनेट मध्ये एवढे सगळे पॅकेट्स मॅक्सिमम जाऊ शकतात. Okay, so if the packet is means it reaches to the maximum capacity, so obviously it will degrade the performance of your network. So that is nothing but the congestion. But it is okay that congestion is happening, but how to control that congestion? So there are two techniques, broadly divided two techniques are available, that are nothing but open loop congestion control and closed loop congestion control. These are the two techniques. Okay, so many techniques or the algorithms are available, but these are the two broadly dividation to control the congestion. Okay, so let's see what is the open loop congestion control and closed loop congestion control. Open loop congestion control policies are applied to prevent the congestion before it happens. This congestion व्हायच्या अगोदर काय केलं पाहिजे? How to control that network before congestion is happening. That is nothing but the open loop congestion control policies or the techniques. The congestion control is handled either by source or the destination in both techniques, that is open and as well as the closed loop. Either source handles this condition or the destination handles this condition. These are the three policies or these are the three techniques which comes under the open loop congestion control. Open loop म्हणजे काय की congestion व्हायच्या अगोदर काय केलं पाहिजे. So these are the three techniques. Okay, let's see one by one. First is the retransmission policy. Then second is the discarding policy, and third one is the acknowledgement policy. Okay, retransmission policy is what? It is the policy in which retransmission of the packets are taken care. If the sender feels that sent package is lost or corrupted, the packets needs to be retransmitted. So this is obviously we have seen in each and every strategy that जर सपोज पॅकेट जर लॉस झाला किंवा करप्ट झाला तर काय होतं सेंडर काय करतो तर ते पॅकेट रिट्रान्समिट करतो. बट what will happen if without knowing exactly whether this packet has reached or not, खरंच ते पॅकेट रीच झालंय किंवा टाइम लागणार आहे किंवा लॉस झालंय what, exactly जर माहित नसेल, so what will happen, this retransmission may increase the congestion in the network again. Okay, so without knowing the exact position of the packet, if the packet is goes on retransmission, then it will like increase the congestion. So to prevent this type of congestion, a retransmission timers must be designed to prevent the congestion. What is this retransmission? Let's say for example 3 seconds. Okay, so sender has to wait for 3 seconds compulsory. Okay, so after 3 seconds he sender is allowed to send the packet. Okay, what will happen in that case if this timer is not used, so for example for every second the packet will be sent, obviously it will increase the packet size. So to avoid this, the timers are given or timers are designed to prevent the congestion. So sender will send the packet after these 3 seconds only. Okay, in this way congestion can be controlled. So this is the first policy. Then next is the discarding policy. In that, it is adopted by the routers is that the routers may prevent the congestion and at the same time partially discards the corrupted or less sensitive packet. Okay, means suppose ekadi file, yeah, it is given here. Okay, in case of the audio file transmission, what will happen, router can discard less sensitive packets to prevent the congestion. Means एखादा एक packet असा आहे की that is not required or it is not affecting the file, okay, or the performance of the file. So such packets can be discarded by the routers. So this is called as an discarded package. Those who are having those the packets, those who are corrupted or those who are less sensitive, so that are discarded by the routers. So this is called as a discarded policy. This way the um, means packets or the number of packets can be reduced. The next is the acknowledgement policy. So obviously acknowledgement means what? Packet sent झालाय, receive झालाय or not. So that acknowledgement should be sent by the sender as well as the receiver. But what happens is that we have seen one algorithm or we have seen one uh, protocol, that is stop and wait protocol. What was that? Can anybody tell what was the stop and wait protocol? I'm drawing the diagram over here. I hope you will understood what is this. Yeah, what is stop and wait protocol? This is sender and this is receiver. Yeah, can anybody tell what is stop and wait protocol? Yes, what is stop and wait protocol? Don't know, don't remember. Hmm? Yes, rule number 60. Shubham.
Yes, ma'am.
What is stop and wait protocol? Do you remember?
No, ma'am, I don't. Sorry.
Okay, can anybody tell? Anybody is remain? Yes, stop and wait protocol. See, this is sender and this is receiver, right? So according to the stop and wait protocol that we have seen, or generally what is expected in a network, that I'm telling, that suppose sender has sent one packet. Okay, this is packet A. Sender has sent this packet. Okay, so it is expected that receiver should send an acknowledgement for this packet to the sender. Acknowledgement means what? That packet has reached successfully. So this is the acknowledgement for this particular packet A. Okay, likewise if suppose sender has sent 100 packets to the receiver, so It is expected that receiver should send 100 acknowledgement to the sender. Okay, so that is the general working within a network regarding the acknowledgement. But what happens for this is that it increases the size of the packet. So obviously now acknowledgement is also a set of information and packet is also a set of information, so it increases the load on the your network. So instead of sending the acknowledgement for each and every packet, according to the acknowledgement policy, it is expected that acknowledgement should send for n packets only. So let's say for example 10, n is 10. So when the sender sends 10 packets, then only receiver should send an one acknowledgement to the sender. What will happen for this is that for 10 packets only one acknowledgement, so obviously it will reduce the acknowledgement packet size. Am I right? Okay, so that is nothing but the acknowledgement policy. So this will reduce the burden on your network, and we can we can have a control on the congestion. I got one answer: send one data packet at a time with the acknowledgement. Yeah, it is okay. Okay, so this is an acknowledgement policy. समजलं? Yes, have you understood? Yeah, okay. Next is the closed loop congestion control. Okay, closed loop congestion control. So it is a technique which is used to treat the congestion after it happens. Means open loop is what to be done before the congestion व्हायच्या अगोदर काय करायचं, and closed loop is what if congestion is occurred, then what to be done or what how it can be controlled. So that is nothing but the closed loop congestion control strategy. These are the two techniques and which comes under a closed loop control. So first one is the back pressure and second one is the choke packet technique. Let's see what is this back pressure. Okay, now just see the diagram instead of reading all this. I'll show you within. Uh, it is very easy. What is the back pressure? So see, this is the source and this is the destination. Okay, some packets are sending from here and there. So this is source is sending the data to the destination. Okay. Now what happens is that, for example, at this third package, congestion is occurred. इथं खूप सारा लोड झालेला आहे here. Okay, खूप सारा लोड झालेला आहे थर्ड पॅकेट वरती. नाउ व्हॉट विल हॅपन इज दॅट इन केस ऑफ द बॅक प्रेशर टेक्निक, congested node stop receiving packet from the upstream node. ओके, जर कंजेशन ऑकर झालं तर हा जो नोड आहे तो काय करतो, तर याच्याकडून इन्फॉर्मेशन घ्यायचं स्टॉप करतो. किंवा ह्याला रिस्पॉन्ड करायचं स्टॉप करतो. ऑब्विसली वन्स दिस स्टॉप दिस information or stops the taking information from the upstream node, this second node will also do the same. Okay, जर ह्यालाच information आली नाही, okay, how the next information will reach to the second node? So it is not possible. So obviously second node will also stop the information from third node. Similarly first will follow the same. So it follows the node to node back pressure technique and it controls the congestion. It is very simple. जर एखाद्या नोड वरती लोड आला किंवा कंजेशन ऑकर झालं तर तो काय करतो की आपल्या नंतरचा जो नोड आहे त्याच्याकडून इन्फॉर्मेशन घ्यायचं स्टॉप करतो. याच्यामुळे काय होणार आहे, जर माझ्याकडे इन्फॉर्मेशन यायची स्टॉप झाली तर ऑब्विसली माझ्या नंतरचा पुढचा जो नोड आहे त्याच्याकडे कुठली इन्फॉर्मेशन जाणार आहे, नथिंग ना. सो इन दिस वे दिस टेक्निक इज एक्झिक्युटेड. and the congestion is controlled. It is easy. So this may cause the upstream node or the nodes to come congested and rejects the receiving data from the above node. So obviously second will not have any data as third is not receiving. So obviously first will not have any data. So this is called as a back pressure technique to avoid the congestion if it is occur. And the second one is the choke packet technique. Okay, this is just an information of whatever I have explained. So choke packet technique is what it is applicable to both virtual network as well as the datagram subnet. A choke packet is a technique, is a packet sent by a node to the source information of congested. Each router monitors its resources and utilizes at each of its output lines. Whenever the resource utilizes exceeds the threshold value, yeah, if it exceeds the threshold value means capacity of a network, which is set by the administrator, the router directly sends a choke packet to the source, giving it feedback to reduce the traffic. How it works in this flow, if the resource capacity of that particular network, if it exceeds that capacity, then router directly sends a choke packet. So router काय करतो तर सोर्सला एक पॅकेट सेंड करतो टेलिंग दॅट स्टॉप सेंडिंग एक्स्ट्रा पॅकेट्स or reduce the flow of the traffic. Means त्याच्यानंतर once this source gets this choke packet, source will stop sending the data. Okay, and the congestion will be controlled. So this is called as a choke packet technique. Okay, so actually these techniques are not asked ever आतापर्यंत कधीही विचारलेले नाहीयेत. फक्त just remember that there are two techniques to control the congestion, that are nothing but the open loop techniques and the closed loop. Open loop means what? Before congestion what should be done, and closed loop, if congestion occurred what should be done. Remember these two categories only. Okay, and you can go through it, it is very easy. And the last algorithms I want to discuss is the related with the traffic shaping. There are two algorithms for this concept. These are nothing but the leaky bucket algorithm and token bucket algorithm. Okay, now what is mean by the traffic shaping? It is nothing but the managing the flow of data. ओके, सो ट्रॅफिक शेपिंग म्हणजे काय की नेटवर्क मध्ये डेटा कोणत्या रेटनं फ्लो झाला पाहिजे तो मॅनेज करायचा. दॅट इज नथिंग बट द ट्रॅफिक शेपिंग. रिमेंबर, right? So it is about regulating average rate of the data flow. You can see here average rate of the data flow म्हणजे नेटवर्क मध्ये कोणत्या रेटने डेटा फ्लो झाला पाहिजे. सो वाय इट इज रिक्वायर्ड? सो ऑब्विसली अवॉइड टू कंजेशन. ओके, जर डेटा स्मूथली फ्लो झाला तर ऑब्विसली कोणत्या राउटरवरती बर्डन येईल का? नो. Okay, so to avoid the congestion control, this traffic shaping is required. It is the method of congestion control by providing shape to data flow before entering the packet into the network. So before entering packet into the network, that flow of that packet should get maintained, and it is called as a traffic shape. Okay, so these are the two algorithms, leaky bucket and token bucket. So I'll show you the diagram. It is very easy. These two algorithms are very easy. Just the aim be, remember the aim behind these two algorithms. Aim काय आहे की फ्लो मेंटेन करायचा डेटाचा. ओके, लेट्स सी. फर्स्ट इज द लिकी बकेट अल्गोरिदम. इट इज ओपन लूप अल्गोरिदम. Okay, open loop algorithm is before entering packet into the network what should be done with that packet, so that is decided in a leaky bucket algorithm. It prevents the congestion with the traffic shaping. Source incorporates infinite internal queue into which all outgoing traffic is made to wait. Means one queue is maintained in which every packet is available within that queue. That queue is processed at a constant rate thereby. Once all the packets are arrived, so that packets are maintained at a constant rate. If queue length is exceeded, packets are dropped. ओके. जर खूपच लेंथ जास्त झाली किंवा पॅकेट जास्त झाले तर त्या पॅकेट्स काय होणार आहेत, ड्रॉप्स होणार. So I'll show you the simple diagram from which you will get understood what is leaky bucket algorithm. Okay, you can see here. So these are the two conversions or two comparisons. Compare this diagram with this one and compare this diagram with this one. Okay, how the data is maintained. So this is one tap is there and the flow of water is there. Okay, so if we open the tap, full tap, if we open, so what will happen, so too many water will be there in a bucket, and once the bucket get full, the rest of the water will be out of the bucket and it will go wasted. ओके. जर खूप एखादा नळ आपण फुल सोडला आणि ते पाणी काय होणार आहे, त्या फुल स्पीडने येईल आणि ज्यावेळेस बकेट फुल भरेल त्यावेळेस काय होणार, रेस्ट ऑफ वॉटर काय होईल तर बाहेर पडेल. इट इज सिम्पल स्ट्रॅटेजी. सो इफ वी ड्रॉ दिस ऑन अ फिगर, सो regarding the data or comparing the data, so if the flow of the data is too high, so this will be the representation, and once means if get reduced then this is the representation, is there is no continuous data flow is available, right? Now in the same situation, if suppose your bucket is leaked, means bucket la ek hole hai tumcha, okay, and if we maintain the incoming as well as the outgoing data flow continuously, so obviously what will happen, it will miss bucket will not full, bucket full होणार नाही, so obviously packets will not get lost, also this data will be get maintained continuously. If the flow of incoming water as well as outgoing water from the bucket is maintained, then there will not be loss of the water and the water will flow in a continuous manner. Same thing happened with the data also. Now I'll show you the representation, one more representation. Okay, so that was related with the representation of the data. Now just see here. This is one tap. Okay, the flow of the data or the water is maintained here also, and there is a hole, means at some rate or at some fixed flow, this water is coming out of the bucket. Okay, due to which the bucket will not full anytime and the water will not be out of this bucket, so it is an water. Okay, so leaky bucket with the water, same is applicable for the packets, leaky bucket with the packets. So how it is done, so packets are maintained at a certain flow before entering into the network. So network मध्ये यायच्या अगोदर त्यांचा flow maintain केलेला आहे, means after 2 seconds the packet will be sent, after 2 milliseconds this packet will be sent, so continuous flow will be maintained before entering the packet into the network, as well as once it enter into the network, its outgoing flow is also maintained. Okay, so what will happen, so no extra packet will be available within the network, it will maintain the flow of incoming as well as outgoing packets. Have you understood this algorithm? It is very easy. You have to just remember these diagrams. You can write or you can have any explanation regarding this leaky bucket algorithm. Any doubt? Yes, any doubt? No doubt. Good. So next, last algorithm is the token bucket algorithm. Okay, so the next algorithm is the token bucket algorithm. So same situation is there. So instead of direct packets are sent from the network, at the first in this first algorithm, What is this? So packets are coming out of the network and its flow is maintained over here, right? Now, in case of the token bucket algorithm, what happens is that before entering the packet in a network, the tokens are maintained over here. Okay, you can see here. The bucket holds the tokens. Okay, diagram, I think it is not visible totally. So it is given as the bucket holds the tokens. Means this bucket will have a token. And how the flow is maintained. So the packet which is having the token that only allowed to send out of this network. ज्या पॅकेटला फ्लो व्हायचा आहे नेटवर्कमध्ये त्या पॅकेटला काय गरजेचं आहे तर टोकन गरजेचं आहे राईट ॲज लाईक विच अल्गोरिदम टोकन रिंग अल्गोरिदम वी हॅव सीन ज्या नोडला इन्फॉर्मेशन सेंड करायची किंवा डेटा सेंड करायचा आहे त्या नोडला टोकन असणं गरजेचं आहे सिमिलरली the packet those who want to flow within a network that packet should have a token. So after every second, it is given here, huh? One token is added to the bucket after every time, means whatever time is given. For example, 1 millisecond. So after 1 millisecond, every 1 millisecond, one token is added in a bucket. Okay. So obviously, one token, then one packet, then next token, then next packet, then next. So within this continuous flow for every 1 millisecond, token will be added, packet will be flowed. Token will be added, packet will be flowed. So that is the way how this token bucket algorithm executes. Hmm. So see, you can see here, a token is added at every t time that I have told you. So the bucket can hold at most b tokens. So the capacity is obviously decided. If the token gets exceeded, then it is discarded. जर एक्सीड झाली त्याची कॅपॅसिटी पेक्षा जास्त तर ते डिस्कार्ड होतं. When the packet of the m bytes arrives, m tokens are removed from the bucket and the packet is sent to the network. So whatever uh, tokens are required to send any packet, that much tokens are generated for every second, and once every packet will get an token, that will be sent to the network. Okay, if less than n tokens are available, no tokens are removed from the bucket and the packet is considered to be non conformant. Okay, non conformant means what? Suppose एखाद्या पॅकेटला 10 tokens required आहे but that 10 tokens or that is the not capacity of this particular network or particular bucket. So in that case, that packet will not be sent to the network, and such packets are called as the non-comfortable conformant packets. Okay, so these are the two algorithms. First one is the leaky bucket algorithm, and second one is the token bucket algorithm. Both are the open loop algorithm because the strategy is applied before entering into the network. Okay, and these are the congestion control algorithm. Whatever we have seen, these are the techniques, huh? These are the policies: retransmission, acknowledgement, discarded, and all. And these are the two algorithms for the congestion control: leaky bucket algorithm and the token bucket algorithm. Okay, this is the difference between the token bucket and the leaky bucket. So quickly I'll show you. So token bucket, it is token dependent, means token is required. In leaky bucket we don't need a token. In case of the token bucket, if the bucket is full, tokens are discarded but not the packet. Is only tokens are discarded, packets will not be discarded. But in case of the leaky bucket, if the bucket is full, packet or the data can be discarded. In case of the token bucket, packets can only transmitted when there are enough token. Means every packet should have a token to pass in a network. In case of the leaky bucket, packets are transmitted continuously. Means flow is maintained, and within that flow, the packets are transmitted. It allows the large burst to be sent faster rate after that constant rate. Means at a time if 100 tokens are available, 100 packets can be sent in case of the token bucket. But in case of the leaky bucket, it sends the packet at a constant rate. Means one by one only the packets can be sent. It saves it saves the token to send it. Means it has a token to send the packet, but leaky bucket algorithm will not save any token because token is not used in the case of the leaky bucket. So this is the general difference between the token bucket and the leaky bucket. Okay, so here we'll stop here. Only one point from this chapter is remaining, and that is actually in every question paper if you go through, so minimum 3-4 questions are asked on a single point. So that's why I have kept it as a separate point, that is related with the internet working. So it contains how the addresses are formed. That is, suppose my network address is 168 point something point something likewise. So what is this 168? What is this how these are formed, what it called, what is the classification? So that part comes under this. So it will require some half an hour, but I'll take in it in other lecture. So only one point is remaining from the last chapter. Otherwise rest of all the things or all the points I have covered. If you have any doubt still, you can ask me. Otherwise, we will stop here. Instead of giving the roll number and or if you ask the